now I can put you to sleep before that drive home. So we're going to talk about charge controllers and what we currently offer and get down in the weeds on some of them. And like the last one, you all know me, Ryan Stankiewicz with MidNite. Feel free to stop me anytime through here, ask questions, make jokes, whatever. So hopefully most of you are familiar. Oh, wait, my screen is probably not changing, is it? How's that? I bet you can see it now. Everybody see it? Okay, perfect. So most of you are probably familiar with the Classic, but I'll go down in the weeds on it anyways. It's one of the industry's most powerful charge controllers. It's one of the most flexible charge controllers. Another thing that it offers you that a lot of the other ones don't, like arc fault and ground fault built in, so there's just a lot of functionality. We already talked about the Ethernet stuff, but we'll talk about that a little bit more. Some of the things that set the Classic apart from the competition. We offer it in 3 different voltage levels. So if you do need to run a little higher voltage, be it a long wire run or a hydro that you're trying to use or something like that, you can do that. But if you can run at a lower voltage, you can also do that and save a little money on the controller itself. We support up to a 72-volt nominal battery, allowing you to charge up to 100 volts. We include ground fault protection and arc fault protection on every Classic built, except for the SL, but we'll talk about that in a little bit. All Classics will do solar, wind, or hydro. It shouldn't be and, should be or. They'll only do one at a time, like we talked about earlier. If you're doing a wind turbine and a solar array, you're going to need 2 Classics. They all have HyperVOC, which is an interesting feature for you guys up there. We'll go into detail on that a little bit. And they all have manual and auto EQ. They're all fully internet capable. You can remote the display, or you can put 2 displays on a Classic if you want. They all do data logging of 380 days, as well as 380 data points over the last 24 hours. They all do Modbus over Ethernet and RS-232, which, for those of you that do anything in the telecom or commercial world, know that everybody wants to talk to everything and pull data from it, in a single data logging device. That makes it really handy. We'll talk about that. Parallel operations, ETL listed, and it is made in America. We do all of our own in-house work. We populate our circuit boards in-house. We assemble everything. We have pick-and-place machines. It's just we try to do absolutely as much in America as we can. Obviously, components come from all over the world. I think the kid casting comes from Thailand. The Classic casting comes from Thailand. The kid casting comes from Canada. So we source parts from everywhere, but we do absolutely as much as we possibly can, stateside. So as Rachel touched on earlier, we did discontinue, I'll learn to talk today, the Classic Light. Classic Light, for those of you that remember, had dip switches and LEDs, and that was it. It was a little cumbersome to troubleshoot or see what was going on. It really required you to use the local app software to do virtually anything other than just make it charge from solar. And the sales just really weren't there. I think what a lot of people did was came in and looked at the Classic Light and realized for a few dollars more they could get the full-blown one with the display and everything. So what we did is we developed a Classic SL, and that's actually stands for Sorta Light. We have a really interesting naming scheme here at MidNite. If you haven't noticed that already, we give things some really interesting names. The SL basically is a solar-only, low-cost version of the Classic. Because it is lower cost, what we really wanted to do was compete against like the Outback FM80. So we took out the arc fault and we took out the Ethernet to make it cost competitive with an Outback controller and give you still all the other functions. We removed a lot of the stuff out of the menus like auto EQ, wind, hydro. Those are all basically just hidden. They're still in there. So if you get into a case where you put a Classic SL in and you really want to make it work on a wind turbine, or you want auto EQ, we can just set a single bit in the Modbus editor and you get all those things back. But just do remember the 2 key components, no arc fault and no Ethernet. It does still do Modbus over RS-232, but it does not do Ethernet. Features are relatively the same. You'll notice that we lose the arc fault, and you'll notice in the communications we lose the Ethernet, and you'll notice we lose the auto EQ. They will stack with regular classics and classic lights. Basically, any classic we've ever built can be connected to another classic using Follow Me that we'll talk about later. And firmware doesn't matter. The only caveat I give to that is the display on here has a firmware package in it because it has a processor, and the control board inside is a firmware package on it. So if you've got 4 classics on the wall and they're all 4 different ages, it's a good idea to label the covers, even if you write on the inside of the cover for Sharpie, 1, 2, 3, 4, because if you take an old display and put it on a new controller, or a new display and put it on an old controller, the firmware is not always compatible, and you can get into just an aggravation there. But there is no need to bring the older ones up to current firmware to have them talk to each other. That's only if there's features in the new firmware that you really want.
Ryan, I have a question.
Sure.
You told us that maybe you got 4 on the wall.
Yep.
And let's say that you got one that has internet and got everything, and the other one would be the SL. Could they be connected together, or?
So at this time, no. But that being said, what we do have is, because we're coming out with all these new products, we have an extremely low-cost communications box that's probably going to be $120, and it will, that's American dollars, but 120 American, and that will connect any MidNite product to it, and then it has a single Ethernet connection. So then you could get all SLs or anything else, plug it into this communications box, and now you have a web server, you have data logging, you have My MidNite, you have an Ethernet connection, a web page, just everything all in one spot.
Okay. Thank you.
Solar, wind, or hydro, and virtually anything else. So one unique thing we did, and I believe the only other one that tracks like this is Morningstar, but we realized that when we did the Outback, one of the complaints we always got in tech support was, I've got a small AGM battery, and every time your controller sweeps, my battery voltage overshoots. And we realized that we were way too slow. Basically, everybody watches things way too close. So when we did the Classic, we decided to make it extremely fast. It's basically going around the processor 100 times a second and looking at what's going on. So it's able to adjust 100 times every second what it's doing. And that allows us to track virtually anything: solar, wind, hydro, DC generation. Virtually any DC source you can find, we can probably track it and charge your battery with it with one of the settings we have in there. Roy Butler, my tech support manager, cringes every time I say that, but just give us a call. We can help you get those set up to do just about anything. It's just amazing. It's kind of neat, and with that down that same line, one of the things you'll run into is on some controllers, if you turn the battery breaker off, the controller will way overshoot on its battery voltage, sometimes to the point of damaging itself. You can take like the Classic or the Morningstar, and they regulate so fast that you won't even be able to see the voltage. Just a little flick in the voltage for about 100th of a second while they catch themselves. So that's something we felt really important. That was really important, and with that, it allowed us to track, like I said, virtually any DC source you can come up with. I've even got people. I had a guy that has 100 pedal bikes, exercise bikes with generators on them, and he's got them all run through diodes and into a Classic, charging a battery bank that's grid tied. Some kind of exercise thing that he did. I really should get pictures of it, but it's pretty cool. So. And as we talked about with Ethernet, RS-232 and Modbus, what that allows you to do is things like this. Allows you as a programmer, or maybe not even a programmer, but somebody that can pull data from different things, to put together things like this simple web page, or you could have a PLC on site that collects data from the Classics and maybe some environmental data for the site, some other things, and reports it back to you. But it's just a real easy way to communicate with devices, and it's an openly published protocol. We also learned that mistake when we were doing the Outback controllers, we made that a proprietary protocol, and nobody can talk to it now. And we decided we didn't want to make that mistake again. So all of our protocols are openly published. Anybody can talk to them anytime. We're glad to help with that. Down that same road, for those of you that ever play FSMA products, we do build a communications adapter that turns our charge controller into an SMA charge controller. So SMA in Germany has a charge controller for their system, but in North America they do not. So they asked us to build this device, gave us a protocol, and we did. This basically allows Sunny Island to just command the classic of what to do, and all the classic data shows up on the Sunny Island in the web box and whatnot. And DC ground fault and arc fault. You guys may not be getting pushed on the arc fault a lot there yet, if you're not getting pushed on rapid shutdown, but it is coming. Your local code will be forcing you to do arc fault on every PV install over like 80 volts, I believe. So just know that all the regular classics have that built in, and every classic built, even the SL, have ground fault. So those both save you a bunch of time and money because they're built right in the controller, no extra breakers, components, etc. It's just done. So it's a real nice feature. And do remember again, I really like to point out, no arc fault in the classic SL. Just don't get caught on that one. So equalizing. When we started doing the equalizing in the classic, we had a bunch of installers complaining on the wrenches list, actually, not about us, but just complaining about equalize. They got into a big heated debate about how do you properly do automatic equalization, and several of them were saying that you have to just keep trying every day until you get there, and others are saying no, because then you're holding the battery at a falsely elevated voltage multiple days in a row. So we did something different in our auto equalization. Everything else about it is the same as any of our competitors, but we gave you a function called skip days. Retry days. Skip days is something we'll talk about in a little bit. And the retry days is basically how many days it will try before it gives up. So if you set it to do an auto equalize every 30 days, and then you set retry to say 5 days, what will happen is on day 30, it will start an EQ charge. If it cannot accomplish it on the first day, it'll retry the second. If it doesn't accomplish it, it'll retry the third. And then on the fifth day, it will give up and say, I'm going to wait for another 30 days. So we've made it just as adjustable as we possibly could for you to tailor it to what you feel is prudent. If you've got an off-grid cabin up there, it's probably only used 6 months out of the year, and the other 6 months you don't want the batteries boiling all the water out because you're not there to fill them. So you may back that way down, but in the summertime you could back that number way back up. Along that same lines, we don't talk about it in the slideshow, but we have what's called skip days. And because I made a mistake and said it, we'll talk about it. Skip days allows us to ignore the absorb and bulk charge for a certain amount of days. This is something that came to us from SMA and Rolls-Surrett. Both of those companies work together to prove that lead-acid batteries don't necessarily need to be fully charged every day if they're not being used heavily. So if you've got that cabin in the woods and you're going to walk away from it all week, you might want to set skip days for 4 or 5 days so it only does a bulk charge once every 4 or 5 days and then a float charge in between that. And that way you're not excessively using water on those batteries, but you still get that absorb charge once every week or 2 weeks to really shock that battery and knock anything off the plates. So that's kind of another neat feature, especially for remote, unattended, unused systems that are going to go dormant for the winter. You can set those skip days to a longer period and not, boil all the water off the battery. LED modes. Classic has a lot of LEDs. Up here, I think you can all see my mouse, but up here in the top of the vent, there's 3 LEDs on the control board, and then there's 3 right here in this smoked cover. And basically they're going to give you status indicators or errors or current limit, etc. You can physically turn them all off in software so they'll never come on, period. You can put them in what we call RIC mode, where they will only come on if there's a bad error. You can put them in LED 1 mode, which will give you visual indicators of like going to float, auxiliary 1 or auxiliary 2 being active, or the follow me blip, which I think we'll talk about in a little bit. Just things like that. LED 1 is where it ships, and it's probably the most useful because at a glance you can look over and say, oh, my vent fan's on, or oh, my diversion is running, or oh, my follow me is working. It just gives you a quick at a glance look. Blinking mode really isn't useful for anything other than making it that all the LEDs blink in a random pattern. Robin wanted that in there for one of the first shows we took the Classic to, and it just got left in there. A lot of people found it kind of cool, especially, at shows, or if you've got a big system, you can put them all in blinky mode, and there's all these lights flashing, so like I said, it's more for just parties or conversation than it is useful. So, upgradable firmware. This is an interesting one. Up until about 6 months ago, we've had a firmware updater for the Classic that was an install package you had to run on Windows. There was, 30 some odd pages to the instruction manual on how to use that firmware updater. It did work good. It was just a little bit of a challenge to get there the first time out. The new updater we have now is not even an install package. It's an executable that just runs, and there's no real setup to it. It finds the Classic automatically, instructs you on the screen what to do, and then sends the file to it when you tell it to. So the firmware update has got a whole lot easier on the Classic, and as it says here, we always will have free upgradable firmware. One of the neat features about that is anytime somebody comes up with something that seems like a worthy thing to put in firmware, we can have the engineering team work on that, and we can get that out to you. Or if somebody finds a bug, I kind of joke because some of our competitors will talk about how their product is bug free, and I would ask how many in the room have an Android or an iPhone, and how many of you think it's 100% bug free. Any manufacturer that makes power electronics and writes software will never be 100% bug free. That's just hands down. So anytime somebody finds something, that gives us an easy way to solve that rather than having to swap the unit out or doing RMA or whatever the case may be. The update is done off a basic USB cable. Because the Classic is basically a mature product now, that cable is no longer included. The first 5 years of its life, when there were firmware updates coming out pretty regular, we did ship every Classic with that cable. So now if you get a new Classic and we do release a feature and you want it, you do just need to pick up a USB cable. It's mini B on one end and regular USB on the other. One of the new firmware updates that's coming out that Robin is hugely excited about, and I'm not 100% sure what I think yet, but Robin has always wanted the Classic to talk. He's always wanted it to talk, and that's about a couple months out now from beta testing on Talking Classics. So if any of you have ever wanted a charge controller that will talk to you, have no fear, it's going to be here soon. The good news is you can disable that feature really easily. We talked about the local app software. We didn't go into a lot of detail about its data logging. I did tell you that it does data logging on the computer every 2 seconds when it's running. But the other thing the local app allows you to do is export data from the controller. So let's say you do have a customer's site or a remote telecom site. You can go out there once a year, plug into that Classic, export all the offline data, we call it, to an Excel spreadsheet to take it back and save it or analyze it, whatever you may want to do. But that is all available to you as well. All of that data that's in the Classic can be pulled through the local app. Another thing you can do with the local app is you can export and import all of the registers. So if you do have to do a warranty replacement on one, you can use the local app to pull all the registers. You install the new one, push all the registers to it, and you're done. There's no setup to it. You don't have to do all the programming. Those are a couple more things you can do. The local app also does graphing, so you can look at the graphing right on the local app and see what's going on. Just a pretty useful tool all around. And again, no cost to that. It's available to download on our website. And we pretty much beat this up earlier, but just to reiterate, anything you can do from the main screen of the Classic, you can do from the local app. And the slide says it works on Mac, so it must work on Mac. I'll have to verify that, though. And whoever it was that asked that question, definitely feel free to email me, and I will have engineering answer me on that. And if there's a problem, they can explain to us how to make it work. But just a good all-around way to program a Classic if you don't like pushing the buttons on the front of it. And I think we beat up the internet monitoring pretty well, too. Again, just a free cloud-based solution. This will be migrating to a little bit different look and a little bit different layout as we release that COM box I talked about, because this will now have to support all products. This will also have, as we get the COM box done, there'll be a way to tunnel back to your products. Anybody that's used the Outback equipment and played with the Mate 3 and the Optics RE will know what I'm talking about. But you, right from the cloud, Outback's cloud, you can go in and make changes to your equipment. And you'll be able to do the same with the new My MidNite once we release that COM box. So with that remote site, instead of having to drive there and make a couple changes, you'll be able to log in here and do that as well. And go ahead.
About the link to is it by Wi-Fi or by wire?
So the Classic itself is a wired connection. So you would connect it to your network somehow with a wire. Now, a lot of people are doing a Wi-Fi bridge that they put right at the Classic, and it connects to the wireless internet. But the Classic itself is wired. The new COM box will be wired or wireless. It'll have an antenna hanging out of it. You can hook it on the wall beside your equipment and connect it to the wireless network at site. But the Classic itself is a hardwired connection.
Another question for you. As far as the firmware upgrade, can we do it? Do you have to be on site to do that, or can you do it through the internet?
Currently, you do have to be on site. We are working towards being able to push firmware once we do the COM box. The real problem is the risk involved with not being there, where with the COM box, it will be able to store a good image and the new image and an original image. So if something goes wrong, it'll wait like 15 minutes and revert back to the good image or whatever the case may be. So that is something we're working on the COM box. We will be able to push updates from the COM box. On the charge controller, of course, it would stop charging when it pushes that update, but should start as soon as it's done. On the inverter, on the other hand, power system, because we have redundant modules, we're going to be able to push updates to one module at a time and keep the inverter online at a little bit reduced capacity. So you'll be able to do a hard push to the inverter system where you push everything at once with the inverter shut down, or you'll be able to do a soft push where you push one module at a time. So if you were on site and just wanted to get in and out, you could do a hard push and update everything. If you were doing it remote, you could do a soft push and do one module at a time, so the customer would never even know you did it. So those are some of the things that we're dealing with at the moment.
I have a question.
Yep.
I think I don't understand properly the difference for the application between the low and high frequencies, and as well if I can use, for example, an inverter, high frequency with a charge controller, low frequency. I don't really understand the difference between low and high frequency, and can I use a low frequency inverter with a high frequency charge?
Yeah, so you shouldn't really have any issues there because the two don't really have to mesh with each other than at the battery terminals. Most all charge controllers are going to be high frequency just by nature. So yeah, there's just really not any issues to worry about there as far as the intermingling of a charge controller versus inverter.
Can I use the low frequency with a big machine that would need high power at the same time? Like, I don't know, like something which
Oh,
is
I think I understand the question is if you're using furniture like a fridge or a washing machine, does it will affect the performance if it's a low or high?
Okay, yeah. Yeah, actually, my finding is, we'll use wash machines for an example because a lot of them now are DC inside. They're variable speed DC motors, and they're just kind of jittering back and forth when they're doing laundry. And with the standard low frequency inverter, you'll hear that in the inverter. If you're near your inverter, you'll hear the inverter going every time the wash machine spins. And as we move towards high frequency inverters, I think you're going to see a lot of that go away because the frequency is so high, the response is much faster. I don't think you're going to see any issues there. High frequency is not new to the battery-based inverter world. It's just never been done a lot because low frequency has always been cheaper, I think is the best way to say it. It's got its limitations, so we have decided to try to pull all the best of the best and do high frequency and give you something as an option.
Thank you.
All right, so data logging, we touched briefly on this, but the Classic stores 380 days of daily totals. In other words, kilowatt hours for the day, high battery voltage, time and float, all the good stuff you're going to need to know to go back and troubleshoot a system or look it over and make sure it's running as designed, that kind of stuff. The other thing it does, which is kind of neat, I've got a fun story behind this. I've always been a wind nut. I had a home-built wind turbine on a 90-foot tower in the front yard, and my wife come to me one day and said, there's supposed to be smoke and fire coming out of the wind turbine. And it was a really high wind event. It burnt itself up, basically, and was literally on fire on top of the pole. And it was about a 1-kilowatt wind turbine. So as soon as things settled down, I went out and looked at the controller, and I was able to go back through these 5-minute data points and find out that the thing was doing 4,200 watts when it caught on fire. So these are kind of cool. They're kind of a nice troubleshooting thing for you, but also a nice tool in your toolbox. If something's acting a little funny, you can go back and actually look at its timestamps for the last 24 hours. It takes one every 5 minutes, and it's just a stamp in time saved in memory, and you can look at that and see what was the Classic doing an hour ago or an hour and 5 minutes ago. And it's just a way to really get your head around stuff, especially when you get into wind and hydro. Solar tends to be pretty boring and usually just works really well. Wind and hydro tends to get exciting. So, the Classic's display is a graphical display. Robin really loves it, but I can tell you, based on the size, that it's really hard to get a useful representation out of that graph of what's actually happening, but it does do it. So if you do want to look at graphs on the Classic, you can, but you're going to be much happier pulling them off onto the local app and looking at them there. Auxiliaries, those of you that are familiar with it, we have two. Auxiliary 1 can be configured as a 12-volt signal or a dry contact. So if you've got to run a 12-volt vent fan, you can set it up for a 12-volt signal. It'll run the Zephyr vent fan right out of there. If you needed to run a 48-volt vent fan, you could set it up as a dry contact and run your 48 volts through Auxiliary 1 and control that vent fan. The 12-volt signal is good for 200 milliamps on Auxiliary 1 and another 200 on Auxiliary 2. And if you look really close and ignore the annoying blinking red arrow, right underneath this silver thing that says Classic 150, which is your Ethernet jack, by the way, you'll see two little black jumpers. And to change it from 12 volts to dry contact, you just move those jumpers left to right one pin. So it's pretty simple to do. A whole variety of different things you can do with Auxiliary 1, from vent fans to what we call waste not mode, where it will divert any available electricity not needed for the battery. We can do things based on state of charge, based on PV voltage, daylight mode, night light mode, etc. Just a whole lot of interesting things there. Auxiliary 2 is predominantly a PWM signal, meaning that it switches really rapidly and it's good for like resistive heating, like electric water and heater or something. The difference being, like if you're doing a diversion load or an opportunity load on a PV system, if you use something that's just on and off, the battery voltage is going to come up, it's going to turn that load on, the voltage is going to sag, it's going to wait through your hold time, and then it's going to turn the load off, the battery voltage is going to jump back up. When you PWM it, you actually vary the ampacity of that load. So you may have a water heater element that draws 50 amps at 48 volts. On auxiliary 1, it's either going to draw 50 amps or 0 amps. On auxiliary 2, we can make it draw anywhere from 0 amps to 50 amps. So we can vary that current that goes to that load and only give it what's left above and beyond what the batteries need. So it's much more elegant, but it does require solid-state relays, and it does require that it's a purely resistive load. Auxiliary 2 can also be set up as an input. It works with the Whizbang Junior, which we'll talk about a little later. And it will also do an interface, what we call logic in, for like a BMS, for lithium batteries, for instance. A lot of lithium batteries have a single contactor, and if something starts to go wrong with them on a thermal issue, they will open that contactor to keep themselves from overheating or overcharging, and that shuts off everything. So predominantly speaking, if something's going to cause a lithium battery to overcharge or overheat, it's going to be the charging source, not necessarily the load. So with that logic in, they can actually send us a signal, either a ground signal or a high voltage signal, and stop us from charging. And it gives them an opportunity to try to balance things out without shutting off the inverter and the load. So it's just another tool. The BMS guys can interface. It doesn't take anything fancy. Like I said, the logic low, if you bring the auxiliary to the battery negative potential, it stops charging. The auxiliary high, if you bring it up above like 10 volts, it stops charging. So most BMSs have the ability to do that pretty easily, and just offers a real elegant, low-cost interface to the BMS. And we'll jump right into the Whizbang Junior. Again, with that naming convention we have here at MidNite, you'll notice that we never miss an opportunity to have some interesting names. The Whizbang Junior is basically a current sense module. It's designed to go on the standard 50 millivolt 500 amp Deltec shunt. It wires up with a single wire, that purple wire right there, into the Classic or the Kid, and it reports back the current going in and out of the battery. And with that, we get to do things like true end amps. We get to do global current limit. So one thing that I'm seeing a lot of now with PV prices coming down compared to the last few years is grid tie systems of battery backup that are horribly overdriven PV-wise. And if the grid goes down, the ability for the PV to drive the battery so hard they can damage them is there. With global current limit, of course, we can back the current limit down into the battery, but not sacrifice that current when we're trying to sell to the grid. That's just another little feature. But predominantly the most important feature this gives you is a full-blown state of charge battery meter. It's going to show you right on the display of the controller the actual percentage of the state of charge, and that is actually temperature compensated for capacity. It knows when the controller goes into float. It recalibrates every time the controller goes into float. So that's always going to be a very accurate number, provided you get the efficiency and the amp hour capacity programmed in correctly in the beginning. But it's going to give you a really accurate state of charge because the controller knows exactly what the batteries are doing, unlike a standalone battery meter that has to operate just on voltage. This one will know when it goes to float and the temperature of the batteries and everything. Another question. Oh, go ahead.
I'm sorry, I got a question for the Classic.
Sure.
I just spoke with someone, and he was wondering why the terminal board is so small. It's maybe a comment or more, not a question, but they have a hard time with such a small terminal board.
Yeah, and that's a very common comment that we in the customer service side of MidNite hear. And the long and short answer of that is that when the Classic was designed, when Robin first designed it, he was trying to build a 60 amp charge controller to compete against the FM60. And once they got it done, they realized how much power it could make, and it all of a sudden became a 100-amp charge controller. But unfortunately, they didn't have room on the board to put bigger lugs. So because it would hold number 4, Robin considered that acceptable. But that has always been a bit of a hassle, because you are right. If the number 4 THHN is brand new, it'll slide right in. And if you have an old Classic, you'll notice the newer ones, I engineered a modification of the terminal block that allows the cover not to be there in the beginning, so you can actually see the box lug. And that helped quite a lot, being able to see it instead of sticking it up inside that plastic thing and trying to find the hole in the lug. But that is definitely an issue, and moving forward, we are definitely beating the living daylights out of Robin. We just had this discussion on the new 200-amp charge controller, because 200 amps is a lot of current, and the first lug was 2 watt, and then the next jump is all the way up to like 350 kc mil. So a bunch of us insisted that we go with the bigger lug, because 2 watt really isn't quite big enough for 200 amps in all situations. So it comes back to that discussion I had earlier with the DR inverter and being able to only get a couple fingers in the wiring compartment. Robin has always tended to box us into the smallest space he can find, and I think the biggest reason he does that is to try to keep costs down. But in this case, it was just basically the way the product was designed. The intent was never to be as powerful as it is, and we got caught, by surprise. And at that time, was all tooled up on castings and everything, and just didn't have room to go to a bigger block, unfortunately.
Thank you.
Something else on the Classic that makes you guys' job just a little bit tougher, we were able to get what we call bonus amps. One of the things that we realized early on in our career, way back in the out back in trace days, was that a controller will make a lot more power on a 12-volt battery than it will on a 48-volt battery. Of course, you're getting a lot more wattage through it on a 48-volt, but amperage into the battery, the controller would run a lot harder on a lower voltage battery. So when we did the Classic, we decided that we could actually get a sliding amperage current based on battery voltage. And what you're seeing here is a representation of that. You'll see that it does 96 amps on a 12-volt battery, but when it's set up for 48 volts, it'll only do 86 amps. And that's just based on a little bit of heat buildup inside. And this is not an efficiency curve. I hear this a lot, like, wow, it's really inefficient. And it's like, no, this isn't an inefficiency curve. This is just simply what it can handle continuous 24/7 without current limiting due to heat. And you will not damage a Classic from overdriving it. It'll just current limit. If it gets hot, it'll current limit, back itself down. So there's no concerns there. This is just a general system design guideline telling you, okay, if I'm going to do a 24-volt battery and I'm going to have a 110-volt PV array, it can do 84 amps 24/7 without current limiting at all. If I did, if I tried to do 120 volts through the Classic and tried to push it to 94 amps, eventually it's going to warm up and back the current down and stabilize at around 82 amps. And a lot of people look at that and say, well, that's a 12-amp difference. So you're saying we lose 12 amps if we run at 120 volts versus 90 volts. And no, that's not the case. The analogy I like to make, if anybody in the room has had the old incandescent night lights, they ran at like 4 watts. And if you grabbed a hold of that bulb, it hurt. It was hot. If you put that bulb inside an aluminum box and turn it on, that box is going to get hot. So basically, the difference you're seeing here is not the efficiency of the Classic, it's how much heat the components are making inside, causing the box to get hot, and therefore we have to back the current down just so that we don't damage anything. So these are just general system design guides. They're not, like this, they're not cast in stone. The top line is the current limit. That's what it's going to be set at. The max is going to be set at, and typically in a solar environment, it ramps up through the day and it ramps down in the evening. And especially in an off-grid environment, we usually design the system such that it'll carry through most of the bad days. So the good days are just gravy, and you're going to be in float, and the current's going to be regulated anyways, which brings me to my next topic, which is the Classic can be overdriven, grossly overdriven if you want. So if you've got an off-grid house and you really want to design around those bad days up there where it's snowing and you've got clouds, you could take and put the ability, you could take this Classic right here at 2,700 watts on a 24-volt battery. You could put 5,000 watts on that. The Classic is only going to produce 94 amps into the battery on a good sunny day, so it's going to current limit and throw away 94 amps. But on a cloudy day, it's going to make a bunch more power. If you're doing a battery-based grid tie, of course, that wouldn't make a lot of sense because on the good days, you're throwing away a lot of energy. But in a typical off-grid system, you're going to design around the cloudier days. On those sunny days, you're not going to need all that power anyway. So it is okay to overdrive any of our charge controllers. The 200-volt Classic power curve, exactly the same ideas, just different currents. The one thing I do want to point out, I don't want to go over all the curve with you and bore you on that, but I do want to point out that the Classic numbers, we get a lot of misconception on that. So you got a Classic 150, and its MSRP is $850. You've got a Classic 250, and its MSRP is $1,050. So it's cost more money, and it's a higher number. It must be a better controller. And you'll notice that, again, these current numbers go down as we go up in voltage. And again, simply that's just because of the heat in the components. You take a 4,500 watt array, and 0.5% in efficiency is a lot of power, and that creates heat. So the 250 may be 0.5% less efficient than the 150, which current into the battery really doesn't amount to anything, but heat in the components adds up quick. So that's basically the reason you'll see these lower numbers, and as we go to the 250, you'll notice the numbers get even lower. So that's just something to keep in mind. The other thing that I like to point out is, I wish we hadn't have done this, but they made the Classic 250 work on a 12-volt battery. In my opinion, if you're doing a 12-volt battery, you don't really want that high of a PV voltage. Go ahead and go for 150 or 200 and keep your PV voltage down, because anytime you spread those two voltages apart, when your PV voltage and your battery voltage, the farther you spread them apart, the more heat you're going to make in a charge controller. And that's true for anybody's charge controller, not just ours. The bigger that delta is, the more heat you're going to have in your components. So you ideally want to size it enough that the MPPT has headroom to work, but not so much that you're just creating a bunch of heat. We used to say you go one nominal voltage above. If you're doing a 12-volt battery, you try to do a 24-volt PV array. Now I like to say do around 150% of the battery voltage. That'll get you, that's your minimum. That'll get you in the ballpark, and anything above that is gravy, but if you go too far, again, you're creating some heat. Now, there's sometimes that it's okay for that. If you've got a 1,000-foot wire run and you want to save some money on copper, you can use a higher voltage controller, and that little bit of inefficiency, that little bit of heat loss is made up by the cost savings in the wire. We talked about the clipper a little bit. The big clipper for the Classic, basically, as we talked about, is designed to be either a standalone device just to control a wind or hydro from over voltage and over speed, or it can be connected up to our Classics. And when it's connected to the Classics will actually slow the turbine down as the battery gets full. So if you've got a wind turbine, you can watch that turbine actually slow down in speed as the current going into the batteries drops, to the point where when it goes to float and it's just a trickle charge, it may even just stop the turbine. So that's kind of a neat feature because it saves wear and tear. They're available in AC or DC models, and they're available in a 1.5 kilowatt and a 4 kilowatt model. So pretty flexible. All sorts of different ohmages. They have built-in resistors as a diversion for the turbine itself, not the battery, just to keep a load on the turbine. So, string sizing tools. Most of you probably have played with a string sizing tool from some manufacturer somewhere. The Classic string sizing tool is a little unique because it has to accommodate 4 different models. We don't actually make the KS anymore, but we still show it on our string sizing tool. In a nutshell, what you need to know about this is you're going to put in your parameters over here. You're going to pick your number of modules in series, your number of parallel strings, You're going to submit those parameters, and it's going to populate all this. You're going to get some data about the PV array up here, which is good data, but where you really want to run with this is right down here. This is going to tell you right away whether your design was sound or whether you need to go back and look at it. And as you can see in this case, the 150 says it's always in HyperVOC, and conveniently I should put the HyperVOC slide ahead of this, not after it. But we'll talk about HyperVOC in a little bit, and I'll explain that. But this basically means that the controller will never turn on. The voltage will always be too high for that controller. But you'll notice down here that the array size is okay. It's just the voltage is extreme. Then you'll notice when we go over to this one, it's going to run down to negative 75 degrees C, which if we get that cold, we've probably got bigger problems. And it's okay on the Classic. A single Classic is all that's required. Everything's good. Everything's green. Everything's good. You'll notice as we move over, though, this array starts to get excessive for these controllers. And this goes back to that being overdriven statement I made. You'll notice that 1.1 Classics are required, and it's still green. And before you call, no, Marco cannot get you a 0.1 Classic. You would have to get to. I have gotten that call before. It says I need 1.4 Classics. Where do I get the 0.4? I'm sorry, you have to buy the whole other one. So that all being said, what this means is, in a nutshell, we're still happy with this because a PV array typically does 80% of its nameplate. Unless you live in a really bright environment. And sometimes when it gets cold and the snow and reflections, we do get well over the nameplate. But as a general rule of thumb, you're going to get about 80 watts out of a 100-watt module max. And that's because the module is rated in what we call standard test conditions. And you guys can't see my air quotes that I'm making here, but when a manufacturer makes a PV module, they flash it with a bunch of light that represents 1,000 watts per meter squared, and that's how they rate it. In the real world, on the surface of the Earth, at the angles and everything that we're dealing with, we get about 800 watts per meter squared. So what that means for you is that you can go up to 1.2 Classics before you're really going to even hit the current limit. And again, knowing that we can go well over, 1.5 to 2 times more than Classic can handle without any damage, there are times when you may want to overdrive that. So again, way deeper in the weeds than you probably want to be on this, but know that this is the meat and potatoes of it. This line up here will let you know roughly how many modules can we put in series on this controller. So even though you picked 4 over here, we're going to show you up here that if you was to put 3 in series on this 150, it would work great. So then you could go back down and pick 3 and recalculate. You can print these results, and you can also save them as a PDF. Okay, so now we'll talk about HyperVOC, and I will reverse these slides after the show. HyperVOC is a non-operational safety zone. For those of you that have designed PV arrays, solar arrays, in the climate that you're in up there, similar to the climate I'm in here, just a little bit colder, we've always had to worry about what's the coldest temperature ever that we're going to see. And that's how we pick, we calculate our VOC of the array based on the record cold that you're ever going to see in Montreal. Now, with HyperVOC, we get to do that based on the average cold. Because as you know, like I know, we get maybe 1 or 2 days a year where we get near that record cold. Every time else, it's more of an average cold. So what happens in HyperVOC is when that PV module exceeds the operating voltage of the Classic, it goes into a non-operational zone. Nothing turns on. It stays safe. It doesn't blow up. And as soon as the sun comes up over here and warms the module up just a touch, that voltage drops. The controller wakes right up and starts working. For those of you that aren't familiar with this effect, a PV module, its voltage will rise drastically as the temperature of the module decreases. And the same holds true on the other end of the spectrum. When you get a really hot summer day, the PV voltage drops as the panel voltage rises. So not only do you have to worry about the cold weather stuff with HyperVOC, you have to worry about the hot weather stuff. So that's just some stuff to think about. But the HyperVOC gives you a little bit of leeway in that design. So if you're going to do 3 60-cell modules on a Classic 150, you're not going to hurt it in your environment There may be one time a year where in the morning it says HyperVOC for an extra 15 minutes, and then it wakes up and goes to work. It just gives you that little bit of cushion to not worry about damaging or destroying your controller. Follow me. I'll try to pick up the pace a little bit here. I don't want to keep you guys all night. Follow me allows the Classic to share its charging stages. Unlike what we did at the Outback company, we do not have a hub. We do not have all that. It uses standard phone cable. And basically what it's going to do is it's just going to, one Classic is going to ask its neighbor, what are we doing now? And it's going to say, okay, I just went to float. So that one's going to say, okay, I'm going to go to float. And then it's going to tell its neighbor it's time to go to float. So it's just simply coordinating the charge stages, float, equalize, absorb, etc. It will carry ground fault errors across the network. It does not carry arc fault errors across the network because arc fault is specific to the PV array. So if you've got 3 different Classics and 3 different PV arrays, and array 1 has an arc fault, you don't really need to shut down array 2 and 3. You probably don't want to shut down array 2 and 3. So arc fault is specific to the array. Ground fault is a system fault, so it does shut down all controllers. We talked about third-party software. This is a piece of software that was written by an avid MidNite fan. He was really sick of his Outback mate, so he wrote this software. It's up on our website for anybody that wants it. But it talks to their AXS port and allows you to do all your programming on your Outback in common English over here on a web page instead of having to poke through the mate. But that's just some of the things that are possible once you openly publish your protocol. And as another example of a web page using the openly published Modbus. And support. This actually should be at the end of the slideshow, and I do apologize. These are 2 brand new PowerPoints marketing just gave us. So you were the first one to see this, and even though I've practiced it, the slides are a little out of order. But basically, here at MidNite, we have several ways you can get a hold of us. We have the phones. We have an online portal. If you go to our website, there's a link that you can follow to click submit a trouble ticket. So if it's after hours or it's on the weekend, you can do that. You will find that most of the times, even on the weekend, if you submit a ticket, Jim Parrish or myself or maybe even Roy is going to answer you. So you're going to get there's a lot of people always around. If not, there's always the forum. There's a lot of great guys on the forum that know our product inside and out, and are always more than welcome to help and offer advice. Just be aware they are not MidNite employees, so take that advice with a grain of salt. So I'm going to move into the kid. Any questions on the Classic before I do go into the kid?
No.
Okay.
I don't know about you, Ryan, but it's the first time in my life that I see such good students here at Word, and they're listening to you. It's amazing.
Well, that's good. And see, I figured because I didn't get there that everybody was going to have all these questions for me, So, again, I do apologize for not being there in person, and I do so miss that. This is always a fun event for me. So, we will jump right into the kid. Oh, let's back up. There we go. And Rachel touched on this a little bit, but the kid comes in a matte black or gloss white. It comes in a marine or a standard. So what you see here on the left is the gloss white, and it is the marine version. The difference in the marine version really is the mounting bracket. You see it's got like this metal bracket and the knobs, so you can like mount it to a bulkhead and everything. It comes with the battery temperature sensor, and it comes with some conduit. The standard kid comes with this plastic wall mount adapter, which, as Rachel did point out, anybody that has wired a kid before February of 2017 has probably sworn and hollered at us. And it used to be on the back of the kid, you had to hold the kid away from the wall, wire the terminals up, and then put it back into the wall mount adapter. The new wall mount adapter has a terminal block down under here, and is all wired up to the kid. So you run your wire up into the conduit holes in the bottom, take this cover off of the 2 Phillips screws, and all your wiring is right there. Really easy to get at. So if there's anybody with the old ones and they have the old brackets and they want new brackets, shoot me an email. No charge. I'll get the brackets out to you so you'll have them to replace them, make it a little bit more friendly. The regular kid does not come with a BTS, and one of the biggest reasons that is just simply because we found the kid is usually targeting a lower cost, smaller system market, and a lot of times they don't go for all the features. So rather than burden the base price with that feature, we decided to make an adoption. The kit is a 30 amp charge controller. It has a full 30 amp load circuit. It has an auxiliary output like the Classic. It has an input for the Whizbang Junior, and it also does true 2-wire generator start with feedback. So it's very, very versatile controller. I like to talk about it. You know, Mario is the kid. Real quick story on Mario. Back when we started MidNite, we were working actually in the shop that makes our sheet metal. We didn't even have a building, and we were doing stuff there. And as soon as we moved to our new building, Mario come knocking on the door one day after school. He was in high school, and he wanted a job. And it's like, well, we don't really have anything for you to do yet. And he goes, well, I don't need to get paid. He goes, I just need to be out of the house. My mother says I need a job. So he started hanging around and sweeping the floors. And it was not maybe a month that he'd been there that he was like really focusing on what Bobby was doing on the charge controllers, watching them, learning, helping him solder components on the board, helping him try to repair stuff, you know, as Bobby was designing the product. And he really just took to that. And we let him roll with that. We ended up bringing him on the payroll. We ended up paying him to go to school. He's now a full-blown double E and has 2 charge controllers under his belt and going on a 3rd one. So it's just kind of a really interesting story how he came from, you know, not really knowing what he was going to do to being an electronics engineer and building charge controllers. So it's a lot of fun because when somebody says, I'd like my charge controller to do that, those of us that have been doing this for a long time say, oh, I can't do that. And Mario will say, yes, it can. I can make that happen. And in 15 minutes, you get new firmware that makes that happen. So it's just been a lot of fun. We already talked about the Marine version versus the regular version. And we talked about the lighting controller, but just know that it does dusk-to-dawn, hourly, day and night settings. Pretty much real versatile. The only thing it doesn't really have is a time of day clock. So what I mean by that is you're not going to be able to tell it I want to shut the light off at midnight every night. You can tell it I want it to shut off 4 hours after dark, but not at midnight. A lot of people will end up putting a timer in there if they need that specific of a control, but generally speaking, you don't need that specific of a control for lighting controllers. The other thing we did, and we have taken some flack for this from a couple competitors, but we made standard buttons in a screen. They cost us maybe less than $1 in parts to put that in the controller. So going back to that story of trying to troubleshoot or even figure out if the system's working properly, if you don't have the display, you don't have any real eyes on the system of what's going on. You call the customer, you know, you're trying to figure out what's going on. They've got voltmeters out. They're trying to measure stuff. They may not even have voltmeters. So just by putting all that right in the kit as standard equipment, we've just made it easier, and you know, it just takes a lot of that pain out of there. There's no more worrying about an optional display. And contrary to popular belief, it really wouldn't make the controller less expensive. You're talking, like I said, maybe $1 for parts. It's not enough you'd notice it on the end product. LEDs, similar to the Classic, with one difference. You have these 3 LEDs up at the top that will tell you when the last time the battery's actually been full. And again, knowing this product is targeting maybe a lower knowledge base end user. In other words, what I mean by that is if you're going to install 3 Classics and a couple Radians or something in somebody's off-grid house, they're going to take the time to get educated because they just dropped a lot of money with you guys to install this equipment. If you go install one module and a small battery and a couple lights and a kid, they may just assume it's going to work because it's their hunting camp. They only go up a couple times a year. They're not really worried about it. So this just gives you a little bit more of a quick visual indication of what's happened. You know, the orange light's on down here. This is 2WL. That's letting us know that the controller hasn't been to float in over 2 weeks. So it's just a real quick at a glance of what the heck is going on here. The rest of them are pretty self-explanatory. It's in float. We're in a current limit situation or an over temperature situation. we've got a fatal error, or the blue LED down here comes on anytime the load circuit is operational. This is kind of an interesting feature. As far as I know, I think Morningstar does this on the 600 volt controller. One of the only ones that does this though, and we have the ability to actually put 2 charge controllers on a single PV array. So you can put the 2 kids in what we call twin mode. One basically turns off its control module, if you will, and gets its drive from the primary one. The primary one will control both power centers and display everything on a single screen. So it basically becomes a 60 amp controller. So if you've done a small system and you need to expand it, instead of having to take the controller out and put a bigger one in, you can just parallel a second one on. That does come with some challenges because now you have to decombine the array wires into 2 different controllers, but that's pretty easy to do with most of the equipment we have. So just know that that feature is there. And a lot like the classic, but completely different, we have what's called sync mode on the kids. You can do up to 16 kids in sync mode. And what will happen when you turn the kids on, the first thing you'll see is they'll say looking for other kids. And if they find more kids, they will come up on the screen and say, sync on every one. And on one of them, you'll press the save button. And that one becomes the master of all of the kids, if you will. It takes control. It then tells all the other kids what to charge to, what the battery temperature is, all the parameters. All 16 just do what the first one tells them to do. And that works pretty good. The downstream kids, if there is a fault in the communications cable, will revert back to standalone charging. So when you do set these up, you do still want to set all your parameters on the other 15 kids, such that if there is a fault in the communications, they will, default back and charge to what they're supposed to. That they do auto reconnect if there is a loss of communication. So if you're in a real noisy environment or maybe a dirty connection on the cable and it's intermittent connection, within 30 seconds that connection will be back up. So it's a pretty stable system. It's pretty cool. And that again uses just a standard 4-conductor phone cable, or if you're in a real bind, you can even use 2-conductor phone cable for that. Question on that, or?
No question.
Okay, perfect. So moving forward, power handling.
Got a question now.
Sure, go ahead.
Yes, about the MPPT logic of where you put multiple kits in parallel. I wanted to know if the logic of the MPPT logic, the control of the PV side is the same for each of the, all of the kits which are in parallel. Do you understand my question?
Is a little low on the audio, so somebody could repeat that, maybe a little louder.
It was too far, so
I wanted to know about the control of the
you can just come at the front so you will be able to.
Peut-être dire en français que c'est traduira parce que c'est peut-être.
Non, mais si tu peux avancer parce que le micro il est pas assez fort. C'est pour ça que le micro il est performant. Yeah, okay.
Yes, I wanted to know about the control logic on the PV side of the kit when you have multiple kits connected in parallel. If does the control logic remain the same for all the kits, or each kit has its control logic? This is in the case in which you have multiple strings, and you have each kit has its strings connected, one string connected to it.
Sure. So in twin mode, which if I back up here, maybe I can find it. Yeah, in twin mode, it's a single PV array. So only one kid will affect the the MPPT algorithm and all that. The other one is just switching its power center. But when we go into the sync mode, each kid is actually individually dealing with its own PV array. So if you had 16 kids in sync, you would have 16 individual DC sources feeding each kid. And each one manipulates that source individually to maximize it. The only thing they're doing is coordinating, the battery voltage and when to go to float and all that good stuff. But they're manipulating each PV array individually.
Okay, this means if, for example, you have a PV array which is damaged, the other string will work perfectly with the other remaining MPPT.
Yes. So for redundancy's sake, yes. If you had, say, 3 kids, 3 strings of PV, if this one string got damaged, the other 2 are going to keep working just perfectly. Yep. And the same with the fault. So if one of the kids fails, the other ones are going to just ignore it and keep on doing their thing. So it's a nice redundant setup, especially for remote applications. All right, so power handling. Going back to that theory that we can overdrive any of our controllers without damage, these numbers are round numbers, and this one gets us in trouble sometimes because people will say, oh, well, my distributor has 2 300-watt modules, but that's 600 watts. It's still going to be fine. It's just going to current limit at 30 amps. You could put 1,000 watts into this kit on a 12-volt battery. It's just only going to produce 30 amps into the battery. So these are just general guidelines of where you'd want to design to in normal conditions. But again, if you've got an off-grid system or a unique scenario, we're not going to get concerned if you overdrive it. Something else that I want to point out that I don't think is on any of the slides, and if it is, we can skip it. But you'll notice there's these red covers on the kit. And if you can see that on your screen, it says fuse on the cover. One of the things that we found was on a lot of these smaller systems, the customers, especially the do-it-yourself customers mostly, not installers. Installers always use breakers and everything, but a lot of the do-it-yourself crowd was putting stuff in without breakers. And I can't tell you how many times I've asked somebody to reboot their charge controller or inverter, and you'll hear them, well, I got to get a wrench. I got to unhook the battery cable. You don't have a DC disconnect on this anywhere? No. So on the kit, because it's used in a marine and RV environment as well, and installed by maybe a DIY crowd, we went ahead and built in fuses right in the front of it that are easily replaceable. Now, you still want your overcurrent protection in there just like you would on any other DC system, but that's just a little bit of a safety feature for those systems that may not get installed properly. String sizing tool for the kid, very similar to the classic, but much more simplified because there's only one kid, and the kid is 30 amps period no matter what the battery voltage is. So much simpler to read and follow. Something I didn't talk about on the Classic, but I'll talk about it now. The kit supports a 12 through 48 volt battery system, but unlike some of our competitors, we don't give you windows. So if you pick 24 volts, you're not bound between, say, 20 volts and 30 volts. You could pick 12 volts and you could crank it all the way up to 45 volts. So if you've got a 29 volt battery or a 31 volt battery or any odd voltage, we can adjust to that, no problem at all. It's just adjustable all the way from 10 volts to 64 volts on a kid, and it's adjustable from 10 volts to 100 volts on a Classic. So if a lot of these new technologies coming out in the lithium world, other things, we're seeing a lot of different voltages, and it just made sense to go ahead and make that infinitely adjustable for you. And when you do start the kit up, you're going to get a quick start guide. And interestingly, way off topic, and I digress, but we have language packs coming for the kid. And I'll have to check into that. I need to check into that because I know we have French and Spanish all done. So if you have a kid charge controller, you can download a French firmware and drop in it, and everything on the screen is going to be in French instead of English, or the same with Spanish. So I need to look into that and figure out why we haven't got that up on the website yet. But I just wanted to throw that out there that we are working that way. So definitely beat up on me, and I will push that cart down the road as fast as I can. Like it says here, the kit will support virtually any battery voltage or chemistry. The absorb timer can be adjusted down to 0 minutes. If you needed to feed absorb for like a lithium battery, we can do that. Just extremely flexible, really trying to accommodate any chemistry that you may run into out there. HyperVOC on the kid, quite similar to the classic, except for you're limited to 162 volts maximum on the kid, so you only get 12 volts of headroom on the kid, and that's basically due to the smaller PV capacitors inside it. And mounting the kid. We've talked about this quite a bit already, but the marine version comes with this bracket, the standard version comes with this plastic wall mount adapter, and if you're going to use it in an application like a mobile application or a power center of some form, there's actually a template in the manual that you can put on the wall and trace around. You can cut out a hole in the wall and actually bolt the kid right flush into the wall, so you don't have all this stuff out on the front side, and then you'd wire it from the back side like in a marine or RV or something like that. Firmware updates, different than the classic. The kid still uses the USB cable, but on the kid, what you do is you go into the tech menu and you press firmware update. And when you do, a little thumb drive folder pops up on your computer. Then you just simply grab the file, drag it, and drop it in the thumb drive, and it'll say updating on the screen here. It'll say updated, and then it'll start counting up in percentage. And it takes about 10 minutes to update, and the kid goes right back to work when it's done. Whizbang Junior. Oh, go ahead.
My question about the update of the firmware.
Yeah.
If we we have solved the regulator outside of the Canada and very far without any internet and out of regular circuit. What happens if the client don't do the update?
Yeah, so good question. What happens if the client does not update their kit? For the most part, firmware updates are usually done for features that people want. So usually there's no problem. I can say on the kid that really there hasn't been any real bugs that have been damaging or deal breakers. They've all been little nuances. So for the most part, nothing. It's going to run just fine. The only real reason, and I stand by this, the only real reason to update firmware in any product is because it doesn't do something you want it to do. So if the manufacturer releases a new cool feature and you really, really want that feature, then by all means update the firmware. But if the product is running great and doing everything you want it to do, I would not touch it personally. It's just a can of worms. If it's doing everything you want it to do, why even open that can of worms? So in your case, as long as the customer is happy and it's doing what they need it to do, no update needed.
When you send your projects to Remote, the firmware is updated, or you have to check it before send to the customer.
So I didn't get the first part of that. When what happens?
Let's say that it's sending to the reseller.
Okay, yeah. So the firmware, most of your, I don't want to speak for Marco, but most of the distributors do not unbox and update firmware and product as the manufacturer releases new firmware updates. So let's pick on Marco a little bit there and say that if, let's say Marco bought a lot of kids early on and kept them on the shelf, there's a chance that some of those could be older and the firmware could be a little older. But for the most part, I think most of the distributors do a really good job at rotating their stock and keeping things pretty fresh. And Marco may even unbox them and update them if there's a big update. We had one on the Classic where we released the Classic code and realized within a week that we really had a problem. and we tracked down every single one that was still in distribution, and we either replaced them or took care of the distributor to take the time to update them for us on their level. But for the kid, for the most part, there just really hasn't been any firmware updates that have been any deal breakers, so it really isn't an issue.
To do the firmware, we have to, the system is in service. On the batteries and the PV are installed.
Well, it doesn't have to be in service. So you could actually use just a regular 9-volt Energizer battery to power the kid to do a firmware update. You could use a power supply, anything really. So if you as an installer or a reseller wanted to update it before you send it out, you could just have a little like cell phone charger that you cut the end off, wire into the kid's terminals to power it up to do the firmware update. It does not need the PV running to do it.
Okay, that's perfect. Thanks.
Yep. So Whizbang Junior, I think we beat that up enough on the Classic. Basically, it does exactly the same thing it does on the Classic. It's a single wire hookup, gives you a fuel gauge on the display. And the Brat. So we're going to move on to the Brat. Rachel probably give you all the highlights on this anyways already. It's a pretty simple product. It is our only PWM charge controller. Everything else we do is MPPT. It has selectable charging modes. It does true, bulk, absorb, float, and equalize, and auto equalize. It has an 8-position switch up here, dip switches that you can select the different solar mode or 12 or 24 volt battery, deep discharge on the battery for the low voltage disconnect. Basically everything you need to do is right here on this switch or this little rotary switch. The rotary switch controls all your load control settings like dusk to dawn or on for 6 hours after dark and on 2 hours before dawn. All those different things are controlled on the rotary switch. The dip switches do all of your main hardware like 12 or 24 volts deep discharge. One of the differences with our controller is that if you don't need that load circuit, you can actually flip a dip switch over here which will parallel the load circuit into the charging circuit, and this will become a 30 amp charge control instead of a 20. You do lose the load circuit to do that though. It does support flooded gel and AGM. It does do temperature compensation for ambient. You'll see this little blue wire. There is a thermistor right there outside the case that allows it to monitor the ambient temperature and adjust, but it does not have an external BTS. Another neat feature about it is it actually looks just like you see it here. It is in a clear case, and it is outdoor rated. You can nail it right to a tree, wire up a solar panel, and power a light. It's just, real cool like that. No fans, etc. It does have 4 LEDs up in here. You just barely see them in this picture. And you'll notice on the cover there's some definitions embossed in the cover. One of the things we tried to do on the Brat was put everything you needed to know written on it. So if the owner's manual is thrown away or whatever the case may be, you really should be able to find out everything you need to know right from the sticker inside and the embossment on the outside. The only thing you're not going to get is the blinking patterns for different errors. If the battery's low and the load tries to come on, the load light blinks to let you know it's supposed to be on, but the battery's too low. Like we talked about, lighting controller, probably one of the most versatile in the industry. We took a look at our competition and what they offered, and the rotary switch we picked had about 3 more positions, so we made a few more options and filled it up. Clear UV stabilized case for outdoor rain and bug proof, and again built right in Washington State. All the circuit boards populated in-house, all the good stuff. Does come with the strain release as shown. And I think that beats charge controllers right into the ground, so I'm going to say go ahead and shoot your questions away and we'll see what we can take care of.
That was pretty much complete.
Good.
Yeah. No, there's no question, but oops. Okay.
Well,
just, we've seen the kid Mario, Brad, we're just all anxious to see the Rachel.
See, so one thing you can do, here's an interesting thing that we do at MidNite, is if you go to this tab called Gallery, and you go to MidNite Employees, here, for good, bad, or indifferent, you'll get a picture of every employee that works here. And I think Rachel's actually stepped out. I got a message from her. She had a little bit of an emergency. She had to step away. But she is in here somewhere. Oh, let's see. There she is. So that is Rachel. That is your sales lady that you'll be talking to. She's pretty much the only one we have in sales because we all sort of wear a lot of hats. You may get Roy or I or even Jim Parrish when you call for sales. But this is just usually pretty up to date. This is Kyle. He's new in tech support. Real interesting fella, real sense of humor. So you may get him when you call. Two of our tech support employees is Roy Butler. He's been a long time off-grid guy, wind guy, just a real ball of knowledge. I mean, he's been there and done it and got the scars to prove he learned it the hard way. And we got Jim Parrish here somewhere. Jim is the other one that you'll get in tech support right here. Jim does tech support from his RV. He has a nice little RV that's all solar powered, and he actually has his office set up in it, so he goes out and sits in his RV because he lives in Florida where it's always nice and warm. So I frequently tell him he sucks, especially when it's snowing here, but you know. So you know, this is just you'll find a lot of our employees here, most all of them actually. Production line workers, everything. This is obviously not all of them because we're at about 75 employees right now. But this is usually pretty current. And if you're talking to somebody on the phone, they say, hey, my name is Sue, or you're at a show and you've met Sue, there's Sue. You know, you can go find him on the website. Put a face for name.